stage completely empty of all of its propellants. The first stage lost also basically completely empty. I'm seeing a tiny little bit of fuel. That RB-1 rocket propellant one still first stage tank there, but for the most part, Alneyadi is basically entirely empty of its propellants at this point. So as I mentioned before, we're expecting this to wrap up sometime between 2:30 a.m. and 2:40 a.m. Eastern time. So now at 2:33, we are in that range. So we should be hearing fairly from SpaceX for the Varial, located here at SpaceX control, just behind Gary and I. We should hear from them soon, indicating that the propellant offloading is complete and that we will then prepare to disarm the launch escape system. So for those that have recently tuned in, we had a nominal countdown. The SpaceX team reported an issue with the TEA-TEB, basically the fluids that we use to ignite the Merlin engines. You can kind of think of it like the spark plug to your car if you drive a combustion engine vehicle. So that TEA-TEB is a critical component to getting the rocket to fly. It's what creates the spark for that engine ignition. So we heard around T-minus 5 minutes that SpaceX had an issue, and then about 2.5 minutes later, at T-minus 2 minutes 30 seconds, there was a scrub called in the launch countdown. But as I said, prior to that, we had a nominal countdown. Now just working through this scrub procedure.
Dragon, SpaceX was propellant offload complete. At this time, we have all propellant off the vehicle, proceeding to offload up.
SpaceX Dragon copy.
All right, so that's an important call. Propellant load, or the propellant offload being complete. So we'll be tracking to see when the launch escape system gets disarmed. Right now it's still armed just as a precautionary measure as the ground teams continue to track the
Dragon
propellant.
SpaceX, with that call, you are go for section 2 of 5.100, disarm launch escape system.
And I'm not sure what call that was that you're referring to, as that we are going for 2
And a halt, break.
launch escape system safety.
Hey, copy that. Good read back.
Okay, we are launch escape system safety. We are 2 Alpha 1 and we're at 2 Alpha 2, but this is not the launch escape system.
connection with Dragon Endeavour, as you see on the screen there, white room, connected back in. So as we watch the astronauts can unbuckle, pull up their visors, take a moment to relax and appear on. Commander Chari, looks like they'll be heading out at some point.
They should be, yeah. And at this point, the vehicle's pretty much completely safe. So with the LAS disarmed or safe, there's basically no long active prop in the F9. Very much safe for the vehicle. So they're effectively their procedure 5.100, which is the one they're running inside the vehicle at this point. We're just waiting for the whatever to stay outside the exclusion area while there's any potential taking off. So now that that's safe, those people approach the vehicle. See, they loosen their straps. One of the questions we were talking about while we were listening to SpaceX, why don't they just get out on their own, which they could. But we mentioned before that whole white room is completely open. So they can get out on their own. They may be able to touch a hatch seal, and since all those things run equally pristine, there's no rush right now. There's no reason to risk anything like that. Bumping a visor, scratching something, wearing a rubber seal. So the safest thing to do, since we're going to have to do this again on the next opportunity, is to let the closeout crew come and make sure they help them out, make sure nothing is, nothing gets damaged or anything like that on the way out, and preserve the opportunity, these follow-on opportunities. The good news is the next opportunity will probably go faster because everyone's done it once. They've got some more practice. They don't have to sign the patch, like you said. They knocked that out, so we save ourselves a few seconds here and there. And again, that's for the crew. Although there's the disappointment of like, oh, you didn't go, but it feels a lot like another sim, another chance to proceed, another chance. We talked about once that rocket lights, things happen quickly faster. The more time you have to walk through it, talk through it, and especially in a case like this, you're actually sitting in the seat with the displays up, hearing the vehicle sounds. That in and of itself is a whole worthwhile experience, and it makes you more perceptive if things aren't phenomenal. So the next time if you hear a sound, you're like, well, that's different than what we heard before, and you have a baseline comparison. Looks like Woody's playing with his box settings, so now that their visor's up, they're probably changing their settings just so they're not getting background noise. They're starting to get their gloves out, get their hands out, and just kind of hanging out, relaxing.
Crew 6 did a flag dress just a few days ago. This
Wet dress, exactly, yeah.
So the more experience they get, the better off they'll be for the next attempt. Just to recap, if you're just joining us, we scrubbed the launch attempt at T-minus 2 minutes. Liftoff. There was a hold in the countdown after this 1:08 Eastern time. SpaceX team encountered an issue with the ground system. Triethylene and triethylene boron mixed together, the acronym TEA-TEB. They are the ignition fluid for F9. Ground team couldn't provide sufficient confidence that full load of that TEA-TEB, which is according to light ball 9 of the Berlin 1D engine tunnel about 9. So the team scrubbed it, and now they're going through the procedures for launch starts. And so moving forward, we have some launch opportunities coming up for Crew 6. I mentioned the first one on February 28th. There's also another one on March 2nd at 12:34 a.m. Eastern Time. And if we were to go then, we would begin our NASA TV coverage on March 1st at 9:30 p.m. There will be a docking at 1:05 a.m. Eastern Time on March 3rd. Also want to make a note that there is no press conference. Usually that was scheduled at the in this case, NASA is foregoing the opportunity for a press conference, so stay tuned to your social media channels and NASA's official
start re-entering today. We'll be back alongside you in the capsule shortly and help you with your dress. Additionally, just want to do a quick pumper check. sitting there, and you can see it from someone.
And SpaceX tracking, morale feeling good, just waiting on the opportunity to get out of the gas.
SpaceX has this crew.
Yes, the call there you heard was to give the cruise SA that the recovery crew is going to be approaching because if they do hear bumps or see shadows or silhouettes moving outside the windows, you can't see, you don't have direct line of sight in the room, but you can see maybe some movement or light changes. So that lets you know that the person approaching PMC stands for private medical cruise. As they're doing fine, just waiting to get out.
And so that's going to do it for our coverage of Crew 6. First attempt of Crew 6, the launch of the International Space Station, SpaceX Falcon 9 rocket, Dragon Endeavour. Didn't get to do it today. Roger, we're going to have to wait to see that launch. But good things come to those who wait. And so I want to thank you for being here.
I appreciate it. It was a good fun time. I'm sure I'll get to see a launch eventually. So, as you mentioned, those follow-on launch opportunities. Right now, I'm sure the teams are going to be working, continuing to work through breakfast and lunch to figure out what they can fix the problem. When they're ready to go, so it's safe and ready to go.
Absolutely. Let's eat those, launch, we're ready. And so that's going to wrap up our coverage for this evening. Thank you for watching Crew 6's launch attempt to the International Space Station. Roger Turing and everyone at NASA. Thank you for watching. Have a great day. Climbing inside, they got strapped in to help close out free, and now we are watching them live on May 8th liftoff. We're here at the host desk at the Kennedy Space Center. Raj and I have been counting it down as we went along, and he's been giving us great insight into the whole process of getting ready to launch our mission. Very good.
Very excited to be here. Get to see a rocket launch from the outside. Looking forward to it.
Your first time, as a matter of fact,
Yep.
so we're interested in hearing your reaction after that. But at this time, we are expanding our coverage. I'd like to welcome in SpaceX and NASA commentators joining us live from Hawthorne, California. Welcome to the program.
All right, thank you, Daryl, and hello to all of our viewers. I'm Gary Jordan with NASA Communications.
Production engineering manager here at SpaceX. Gary and I are joining you today from our headquarters in Hawthorne, California. And it's definitely been a very busy evening so far. As we continue the countdown to liftoff, we'd like to welcome you to SpaceX. a final electronic go, no-go poll. But before we can start loading propellant onto Falcon 9, we have a few tasks to look at. First, we need to put Dragon 1 successfully away from the Dragon capsule to its launching position. That will happen between T-minus 44 minutes and 42 minutes. And with that, Dragon 1 will begin the launch escape system armed. Once those two events are completed, Dragon will be ready for Falcon propellant loading. Now, we'll also verify with the launch weather officer that all the weather meets approved restraints. That includes items such as wind speed, as well as maintaining precipitation. However, for tonight, we expect acceptable weather conditions for launch, both at surface level and upper altitudes. As we reported earlier, the possibility of violation for all of those criteria is only 5%. So, pretty good for taking down the thermometer there. As for the range, currently clear for launch from historic Pad 39A. Worldwide network of ground stations and the tracking and data relay satellites, or TDRS, as you hear it called out on the nets, those are ready to support Dragon as it heads into orbit. Today we have an instantaneous launch window at 1:45 a.m. Eastern. Once we begin propellant loading, there is no opportunity to change that T0. The timing for Dragon to rendezvous with the ISS is incredibly precise, down to the exact second. So therefore, we only get one chance to go to space today. But good news, at T-minus 51 minutes and 5 seconds, we are good for launch. Good to go.
Great to hear, Kate. Today's launch marks the 6th time a rotational crew will fly on a commercial spacecraft. And much like our previous crews, today's crew has been training with our team, as they said, for the last several months, running nominal and emergency simulations of what the full mission will look like while seated inside the Dragon. And as with every mission, each one of our crew members brings a diverse set of experiences to today's flight.
That's right, and we'll start with the mission's commander. Steve Bowen was born in Cohasset, Massachusetts. He holds a bachelor's degree in electrical engineering from the U.S. Naval Academy and a master's in ocean engineering from the Joint Program in Applied Ocean Science and Engineering at MIT and Woods Hole Oceanographic Institution. In July 2000, Bowen became the first submarine officer selected as an astronaut by NASA. This will be Bowen's 4th trip into space as a veteran of 3 space shuttle missions: STS-126 in 2008, STS-132 in 2010, and STS-133 in 2011. Bowen has logged more than 40 days in space, including 47 hours, 18 minutes during 7 spacewalks. As the mission commander, he'll be responsible for all phases of flight aboard Dragon, from launch to re-entry.
Warren Woody Hoburg is from Pittsburgh, Pennsylvania. He earned a bachelor's degree in aeronautics and astronautics from MIT and a doctorate in electrical engineering and computer science from the University of California, Berkeley. He is also a commercial pilot with instrument, single-engine, and multi-engine ratings. The mission will be Hoburg's first flight since his selection as an astronaut in 2017. As pilot, he will be responsible for spacecraft systems and performance on Dragon.
Sultan Alneyadi will be making his first trip into space, representing the Mohammed bin Rashid Space Center of the United Arab Emirates. Aboard Dragon, he'll serve as a mission specialist, working to monitor the spacecraft during the dynamic launch and re-entry phases of flight. He spent time in the UAE military prior to becoming one of the first 2 individuals selected by his country when they started their space program just a few short years ago in 2017. Alneyadi will be the first UAE astronaut to fly on a commercial spacecraft.
Andrey Fedyaev will be making his first trip to space and will also serve as a mission specialist, monitoring the spacecraft during the dynamic launch and re-entry phases of flight. He was selected as a cosmonaut in 2012 and will be the 2nd cosmonaut to fly aboard a SpaceX Dragon. Each of these crew members will be a part of Expedition 68 upon their arrival to the International Space Station. Now let's head back over to Kate for another status update on the countdown. How's it going, Kate?
Thanks, Jesse. It's now T-minus 48 minutes and 5 seconds. The SpaceX launch teams are finishing final review of data from checkouts of Falcon 9 that have occurred over the last hour. The launch director has confirmed with the launch weather officer that weather meets propellant loading constraints. So next up will be to poll the team for readiness, both to load propellant and to launch. Therefore, that will be the final poll that occurs prior to liftoff. The 7 SpaceX responsible engineers, often called REs, indicate that they are go for launch and propload electronically, voting on the online countdown procedure. The launch director, or LD as it's called out on the nets, also checks with the Dragon mission director, or MD, as well as the NASA launch manager to make sure that they are ready. Now, earlier you saw the Vehicle Assembly Building, lovingly referred to as the VAB. The Falcon and Dragon launch team, as well as key NASA launch members, are in the Launch Control Center, which is adjacent to the VAB. You have a view of that room there on the left-hand side of your screen. That is Firing Room 4, and they have a view looking straight toward Pad 39A. Now, there also on your screen on the right-hand side, you can see the Dragon capsule. That crew access arm is still in the service position. Inside the capsule are 4 crew members looking pretty comfy and pretty relaxed prior to liftoff. As you can see, that crew on board Dragon, they're waiting for the next instructions, which will be to stow the crew arm for launch and to arm the launch escape system. Now, once the launch director gives the final instructions to the launch team, the crew arm sequence will be armed and initiated. Now, we should get a good view of the access arm as it swings away from the capsule, which will take about 2 minutes to completely move out of the way. Checking in on the range continues to be go for launch there. They are monitoring the clearance area around the launch pad as well as the air and sea space around the flight corridor. There at Kennedy Space Center, the weather conditions are predicted to be acceptable for launch. As I mentioned before, only a 5% chance of violating the conditions, which include winds, both upper and launch altitude, thick clouds, as well as the downrange landing zones. In the unlikely event that an abort is called for in that escape sequence, we have to make sure that the weather for those downrange landing zones is also acceptable. But everything is looking good on the weather front. Now, we are expecting that final pull from the LD to occur here in about 20 seconds. So we will pause and listen in for that announcement.
Pull is complete, and the team is ready for crew access arm retract, propellant load, and launch. Both control rooms will go into lockdown in T-minus 45 minutes and remain in that state until the launch escape system is disarmed. All operators are to remain in their console and maintain a sterile cockpit until MD confirms successful disarming of the launch escape system following orbit insertion of propellant offload in the event of a scrub. For non-urgent no-go conditions, brief the CE or the LD, and they'll approve aborting the launch countdown. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch sequence immediately and proceed into the launch abort sequence. At T-minus 10 seconds, launch control will be hands-off, relying on automated abort criteria for the remainder of the count. Operators advise the launch director whether structural breakup is imminent or occurring for Dragon manual escape flight rules. Launch control may proceed with arming the crew arm for movement.
Now you're looking at a pic of Crew 5.
Leading the crew arm movement.
Dragon capsule endurance, and the booster that you see behind them that they're posing with is a brand new one. Actually, it was damaged in transit from California to Texas. When it was fixed, repaired, they did a great job. SpaceX is getting that all ready.
All right, as you just heard there, that final go for launch as well as for propellant load coming from the launch director, or LD. So all good news there. We are still go for space tonight. As of right now, the crew access arm is being prepared to be moved out of the way. So basically to clear room for the Falcon 9 to lift off. So to follow along with that action live, let's go back over to... And there's that call out for that retraction beginning. Let's go back over to Daryl to follow that live at KSC.
All right, thank you, Kate. Appreciate it. The countdown continuing to tick down as you see the crew access arm moving away. I'm here with astronaut Rajachari. That crew access arm, as it rotates out of the way, is that something that you can feel when it disconnects?
So we talked about that. We definitely thought we sensed the vibration of it. I think we got a little bit of sense of motion from the wind, but I don't know if we were just imagining it or not. Because there's a whole lot of your senses are super heightened right now. Yeah. So we're definitely we actually did talk through. I do remember we talked earlier about how you're kind of going through different scenarios and timelines. And one thing is if there is a emergency egress button in the capsule, well, one of the things, the big difference is now that the arm is swung back, is you definitely want to make sure the arm has swung back towards you in the event of an egress. And that's because you don't want to step out into nothing. Because at this point, the LES is not high, but the arm
So
is
the arm would have
right.
to come
The arm
back.
has to swing back. Yes, and there's two rates. So the arm moves away at a slow rate, but in the event of an emergency egress, it swings back at a pretty quick rate. Rightfully so, because you want to get out quickly.
Yeah.
But that's one of the things they're probably talking through. Like, hey, don't forget, first person out the door, make sure to look down first. Make sure there's that's the big first step.
Yeah.
It hasn't swung back into place.
Great insight there, Raja, on crew access. I didn't know that about it being turned so quickly, but it makes great sense from a safety perspective. And so now, coming up, we expect to hear a call to arm the launch escape system.
Yep, and so the crew at this point, in preparation for that, will be putting visors down. They should have already done all those steps. They'll verify that, and once they get the go, then they will arm LES and get confirmation that it is armed. We talked before about the hatch closed state, so that's also in this phase. That's the way you actually know it's armed is you see the flight computer state change. So it's a command you send to put it into the armed state, and then you know it's happened. When you'll hear sounds, but that's the official way you know it's actually there. And really the purpose of the LES, the launch escape system, is it's both an automated and a manual system. So there's the vehicle is monitoring a whole bunch of parameters, and so one of the reasons they have to do a poll for arming is all the operators on the ground are checking that there's no parameter out of limits that would trigger an escape inadvertently. So you don't want to turn on the system only to have it immediately fire the capsule off. So the first thing they're doing is making sure all the parameters are stable, the telemetry is good, there's no noisy signals in the data that would inadvertently trigger it, and then you arm the system. And then once it's armed, there's the automated abort, and then there's also a manual abort. So I don't know that you can see it in the camera views we have, but there's a handle that sits between Woody and Steve that you can reach, you rotate and pull, that will manually initiate an abort. And so just very similar to an ejection seat where you pull the handle.
I mean, that's a big responsibility for the commander and pilot if you had to pull that handle. You don't want to do that unless you're absolutely certain.
Exactly. Exactly. And so there's the few cases, or if that's why earlier they did all those checks on the loops to make sure that the people on the ground that have the insight to the status of the F9 and the Dragon have the ability to talk to the crew. And so if there was a failure of the automated system, that someone could tell the crew to manually initiate, or there may be some scenarios where the crew may notice something first and manually initiate.
In just a few seconds, we're going to hear Dragon to ground and that announcement for go for section 7.
Dragon, SpaceX, you are go for section 6. Close visors and arm launch escape system.
Okay, section 6.
All right, section 6 is in work.
I think it used to be 7 now.
It is, yeah. So, which is a great sign. They're constantly, like we talked about before.
SpaceX Dragon visors are closed.
Constantly learning and making changes to procedures.
Right. Earlier tonight, we saw a lot of work happening in parallel for the first time. So we had a lot of margin left over. There you can see the white room exposed to the elements outside.
SpaceX Dragon arming and launch escape system.
So that's Steve telling them that they're
SpaceX copies.
initiating the command, like we mentioned. They'll do it. Actually, you can hear this. You can definitely hear this and feel it in the vehicle. There's some valves that are opening that are the Super Dracos, which are the engines that would fire to initiate an abort, and those valves are safed until this point. So this command is essentially unsafing those valves, and you can very definitely hear and feel that inside the capsule.
Those Super Draco engines you mentioned, Raja, capable of moving Dragon half a mile in just 7.5 seconds, equivalent to a peak velocity of 436 miles per hour. Such a tremendous focus on safety because the astronaut lives. are in the hands of SpaceX, and they want to get them out of there as fast as possible
Yeah,
if there would be an
it's
abort.
an impressive system. So actually, we did a flight test of the abort system before Demo 2, and that was impressive to see that thing work. And yeah, just a strong testament. I think one of the key things for the commercial crew program of having launch abort systems on both the Starliner and the Dragon, just a testament to how much we've learned over the years of space flight and try to make it as safe as we can going forward. You heard the call from SpaceX confirming that the launch escape system is armed. The next big thing now that it's armed, now it is safe to start loading prop once they get to go for that.
If there were a pad abort, it would take the Dragon capsule 2.5 miles east of Pad A into the Atlantic Ocean. Dragon would come down under its parachutes, land in the ocean. It would take about 4 hours to remove the crew. We have assets with the Air Force called Detachment 3.
Yeah, DET-3 is what they call it.
Yeah.
Yeah, so there's what's called PJs, or pararescue jumpers. So we use a myriad of assets with the Air Force and Navy to support these launches on both coasts. Basically C-17, C-130s, helicopters, PJs. It's quite a group, and all the more reason we have to look at that whole weather and the port corridor to have that ready if we need help.
Yeah, because if they landed in the Atlantic Ocean, it would take some time to get there. We've got assets along the eastern seaboard. It could take about 6 to 8 hours. So you want those seas to be calm and not bobbing around in the ocean for that long.
Exactly.
All right, we're getting ready to get that propellant load started.
Once they start that load, you'll start making calls for different phases of load, like the LOX, the helium, different things. And the reason they're doing that is, again, you can hear that and feel it inside the vehicle as different valves open and close. You can hear the sounds of fluid flowing, feel some different vibrations. So that's why they're calling those. So the crew isn't aware if something's nominal or off nominal. If you hear a sound without a call, that could make you worry. So that way you know, like, okay, that's the one that we expected to, that valve was supposed to open or supposed to close.
Propellant load has started.
Okay, and there we have the call that propellant load has begun. Big milestone as we count down to liftoff. Now T-minus 4 minutes and counting. Today we'll begin the next 6-month rotation mission to the International Space Station. The launch escape system is armed, which happened just before we began the loading the propellant onto Falcon 9. Meanwhile, the Dragon capsule was loaded with its propellants about a week and a half ago, just a few miles down the road at a facility SpaceX calls Dragon Land. In order to fly, Dragon needs a fuel and an oxidizer. For the fuel, SpaceX uses monomethyl hydrazine, or MMH, and nitrogen tetroxide, or NTO, for oxidizer, and together these propellants feed those Draco engines that maneuver Dragon on orbit, as well as the 8 Super Draco engines that would power the launch escape system in an abort scenario. And again, now that the fueling for Falcon 9 has started, that means the 8 Super Draco engines inside Crew Dragon are ready, if needed, to launch the capsule away from the Falcon 9 rocket in an instant, should there be any kind of emergency associated with the rocket or the pad. Of course, NASA and SpaceX trains extensively for exactly that type of contingency. So now let's head over to SpaceX commentator Kate Tice at SpaceX headquarters in Hawthorne for an operations update. Kate.
Thanks, Daryl. Yeah, exactly right. We're continuing to count down the final minutes. Everything's still looking good for Falcon 9 and Dragon, with the teams reporting no major issues at this time. Now, with the launch escape system armed and Falcon 9 propellant loading underway, we are heading for an on-time launch just under 33 minutes from now. As we saw earlier, or rather heard, Falcon 9 propellant load began at T-minus 35 minutes. Daryl did a great job of explaining the propellants on Dragon. Let's talk a little bit about the propellants on Falcon 9. Slightly different. The first and second stages of Falcon 9 are each loaded with 2 liquid propellants. One is fuel, loaded into a tank at the bottom of the stage. The other, an oxidizer, loaded into a tank at the top of the stage. The fuel that we use to power the Merlin engines is a refined kerosene, referred to as RP1 or rocket propellant 1. The oxidizer loaded on each stage is a densified liquid oxygen, or LOX. Densified meaning that it's kept much colder than typical for launch vehicles, therefore it takes up less volume, which allows for us to put more of that oxidizer into the first and second stages. To ignite the fuel and the oxidizer in the Merlin rocket engine, we use the ignition fluids of triethyl aluminum and triethyl boron, also called TEA-TEB. Now, when TEA-TEB comes into contact with oxygen, it burns, giving off a green-colored flame. Once we have the flame going, we add a little bit of that kerosene fuel into the Merlin chamber, and the engine ramps up to full power. Now, actually, you might see that green flash just as the second stage engine ignites following stage separation. Now, topping off, helium into pressure vessels on both stages also underway. This is used to pressurize the tanks in flight as propellant is pulled out by the Merlin turbo pumps. You can think of this similar to when you're drinking out of a plastic water bottle. You have to put some air back into the bottle in order to keep it from crumpling. So that's exactly what we're doing with that helium. On board the spacecraft, the astronauts are monitoring the systems while propellants are loaded into the Falcon 9 below them. The crew's training in the simulator here at SpaceX headquarters in Hawthorne, California, actually includes playback of sounds recorded in Dragon capsules during recent flights. So even though today is the first day they're hearing it live, they are prepared for these new sounds. Now the range continues to report no problems.
Stage 1 cryo-helium loading started.
They are go to support launch. Weather also continues to look great. Currently winds from the west-southwest at 9 miles per hour. Great conditions. We only have a 5% probability of violation for those constraints, so all in all, looking good. As I mentioned earlier, today we have an instantaneous launch time. So at this point, if we hear a hold for any reason, we'll have to stand down and target our backup launch opportunity, which is tomorrow, just under 24 hours from tonight's planned launch. Now at T-minus 30 minutes and 6 seconds, let's turn it over to Jesse and Gary for an overview of events that we'll see after liftoff.
Thanks, Kate. For Crew 6, the astronauts' flight to station will take about 25 hours.
Now, as we wait for that T0 mark in just under 30 minutes, the ground operations teams are doing a series of system checks to make sure that both the Dragon and the Falcon 9 are ready for launch. You're looking at a live view of our teams at the Cape as they prepare for liftoff. Now, as we wait for that launch clock to hit 0, we wanted to give you an overview of what the ascent portion of the mission is going to look like.
Once we hit T0 and a successful launch occurs, we will watch Falcon 9 and Dragon lift off from historic launch pad 39A and make their ascent.
At 50 seconds into flight, Falcon 9's engines will throttle down to help pass through the period of maximum dynamic pressure on the rocket, or what we typically refer to as max Q. It's worth noting that once we hit max Q, the vehicle will be going supersonic.
Now, once we are through the period of maximum dynamic pressure, we can throttle up our 9 Merlin engines again. From there, at about 2.5 minutes into flight, we have a series of 3 events that will happen in rapid succession.
First is MECO, or main engine cutoff. This is where all 9 Merlin 1D engines shut off in preparation for stage separation, which is our second event. This is where the first stage detaches from the second stage, with the first stage making its way back to Earth for landing, as the second stage continues its journey with the third event, SES-1, or second stage engine start number 1, where the MVAC engine lights up and propels the second stage along with our Crew 6 astronauts into orbit.
As Stage 2 heads towards its targeted drop-off orbit, Stage 1 will execute 2 burns in order to make its way back down to Earth. The first is the entry burn. That's where 3 of the M1D engines will reignite and then shut down again. This helps to slow the stage down in preparation for entry back into the Earth's atmosphere.
While that first stage is heading back to Earth, the second stage will cut off its 1 Merlin engine that was ignited right after stage separation.
engine burn, but it's powerful enough to bring the vehicle speed down rapidly in order to land on the drone ship at about 9.5 minutes into the mission.
While Falcon 9 first stage is landing, Dragon is preparing to separate from the second stage. At about 3 minutes after the second stage gets into orbit, we should have a great view of Dragon with its 4-person crew drifting away from the second stage. Once Dragon is a short distance away, it'll begin checking out its Draco maneuvering thrusters to make sure Dragon continues to increase separation distance from that second stage. It's worth noting that these are not the Super Draco engines that would be used during an abort scenario.
About 40 seconds after separation, Dragon's nose cone deploy sequence will begin. It will take roughly 4 minutes for the nose cone hooks to unlatch and open, exposing its guidance navigation controls that will help Dragon autonomously fly to the space station.
And lastly, once the nose cone is deployed, the remaining Draco thrusters on the forward bulkhead will be checked. From there, over the next 25 hours, Dragon will be on its approach and rendezvous phases, undergoing a number of phasing burns as it makes its way to the station. And all of that will be coming up soon, but for now, let's check back in with Courtney in Mission Control Houston. Courtney.
Thanks, Gary. The flight controllers here in Mission Control Houston are laser focused on the onboard systems of the space station, ensuring it is ready to receive Crew Dragon. They're also making sure all communication links between the station, Dragon, and the ground are working properly. The consensus to this point is that everything is proceeding right on track. The team here in Mission Control Houston, the team in Hawthorne, and the astronauts aboard the space station will monitor the autonomous docking of the Dragon spacecraft tomorrow. They'll perform a series of leak checks, then work to open the hatches on both the Dragon side and inside the station's pressurized mating adapter. We expect hatch opening to take place about an hour and a half after docking. And once on board, the astronauts will be greeted by the space station crew and will then join in for welcoming remarks for the new crew members. From there on out, they will no longer be referred to as Crew 6, but rather as flight engineers of the International Space Station until their return back to Earth. Here in Mission Control Houston, Flight Director Chris Dobbins is on console overseeing the team board launch. And that'll do it from here in Mission Control Houston, so I'll toss it back over to our team in Florida. Daryl, how's it looking?
Thank you very much, Courtney. And we're out here at the Kennedy Space Center. Folks are gathering on the lawn now, getting ready for this launch, and it's a beautiful sight behind us, Roger.
It's looking pretty good. It's a great view, and looking forward to seeing my first launch and watching another turtle go to space.
Yeah, we're going to watch the launch, and we're going to watch you. see your reaction. Well, if you're just joining us, we are T-minus 24 minutes and counting now until the 6th astronaut rotation mission to the International Space Station under NASA's Commercial Crew Program. Commander Stephen Bowen, pilot Woody Hoburg, and mission specialist Sultan Alneyadi and Andrey Fedyaev are strapped into their seats inside Dragon Endeavour. They're in that capsule right there as the Falcon 9 rocket fueling operation is well underway. The launch escape system is armed, and that means Dragon is prepared to launch itself away from the Falcon 9 in case of an emergency on the pad or after liftoff. So far, operations look and sound as expected, counting down to that liftoff at 1:45 and 3 seconds a.m. Eastern Time.
Yep, and we heard the call from the Corps that the Stage 2 cryo-helium load had started, and like they described out at Hawthorne, so far what we've loaded is the gas to pressurize the tanks. Around probably about 3-ish minutes from now, we'll actually start the gas itself. So, like they were describing, you need pressure to move the gas, and you need the actual gas in the locks itself. So, right now they are loading that helium that pressurizes the tanks, and then the next thing will be the fuel and then the oxidizer.
Those inert gases key to pressurizing those, especially the locks. This mission is the continuation of rotational crew flights to the International Space Station from U.S. soil on private rockets and spacecraft that would have been possible without the success of course, NASA SpaceX Demo 2, that test flight now two and a half years ago. Of course, it was the safe delivery and return of crews 1 and 2 that got the operational flights rolling. There you can see inside the Dragon.
See their visors are down and will stay down now since the LES is armed, and you can see they're also not writing or doing anything more at this point with the LES armed. You just have to wait until they're done with the prop loading.
Yep. And you can see now evidence that that liquid oxygen is flowing into that first stage as it super chills the outer skin of the rocket, and then it condenses the Florida humid air into a little bit of a cloud there. Talking about the crew inside, the commander of Crew 6 is Captain Stephen Bowen. He hails from Cohasset, Massachusetts. He's married with 3 children. He holds the title of first U.S. Navy submarine officer to be selected as a mission specialist by NASA. Captain Bowen is also a veteran of NASA space flights, including space shuttle flights on STS-126, 132, and 133.
Yeah, Steve's a veteran spacewalker and just a great veteran to have around the office, and great commander to have for 3 rookies. I think what we've learned about submarines is they're a lot like a space station. Kayla, who's also a submarine, like to say that both things are putting people where people aren't meant to be, and a lot of the systems and ways you have to work together are very similar.
You need good people working together in those tight quarters. Sitting next to Stephen is pilot Warren Woody Hoburg. The 37-year-old is from Pittsburgh, Pennsylvania. He studied aeronautics and astronautics from MIT before getting a doctorate in electrical engineering and computer science from the University of California, Berkeley. During grad school, Hoburg worked as an EMT with the Yosemite Search and Rescue. I've seen pictures of him on a rope scaling Half Dome. Crew 6 will be Hoburg's first flight since NASA selected him to be an astronaut in 2017. He is one sharp fellow, but also a great guy.
Yeah, and also a turtle, so proud to see him going up there as yet another member of our, and super excited. Woody, like you said, just amazingly brilliant, but also just so operationally sound. His time working as basically rescuing people from ridiculous places.
Right.
I mean, we're not talking run-of-the-mill like, off a ski slope. We're talking like off of rock faces and cliffs and just some crazy stuff. And doing that and carrying someone else with you who's injured is no joke.
High-risk rescues. It's incredible what he's been able to accomplish before becoming an astronaut. In role of mission specialist is astronaut Sultan Alneyadi.
Stage 2, RP1 load complete.
Okay, we heard the RP1 complete in the Stage 2. Stage 1 will continue going all the way down to around T-minus 6 minutes. Back to Sultan. He was chosen by the Mohammed bin Rashid Space Center of the United Arab Emirates to be part of expeditions 68-69. The father of 5 spent most of his life in Al Ain, Abu Dhabi, but in 2020 traded it all in for astronaut training in Houston at NASA's Johnson Space Center, and this will be his first trip to space.
Yeah, and so important to have our UAE partners with us, the first long-duration UAE flight. So what a historic moment for UAE and for NASA to be working in partnership with them. Like you heard Hazad mention this earlier, Sultan and him had trained together at Roscosmos, now trained together here, and it's cool to see Sultan now going up there on a U.S. commercial rocket to go to the space station.
And now we just heard the call. The strong back chill has begun. You can see the condensing of the outside air, that super chilled liquid oxygen, both chilling the rocket and, of course, the venting of that LOX going out into the air. Our next mission specialist, Andrey Fedyaev. It's also his first trip to space for the second mission specialist. He's a Roscosmos cosmonaut, and he will be working to monitor the spacecraft during the dynamic launch and re-entry phases of flight. He will be a flight engineer for Expedition 68.
And considering the partnership with cosmonauts riding on Dragons and U.S. astronauts riding on Soyuz, so great to see that continuing. And Andrey, the latest cosmonaut heading up on a Dragon.
And happy birthday to him.
Yeah.
He turns 42. What a way to celebrate. Each of these 4 crew members will be part of the Expedition 68 once they arrive at the International Space Station. At this moment, Raja, what's the crew feeling?
I think it's hoping that everything continues. You've trained so long for this. You obviously don't want to get what's called go fever, when meaning you're going to ignore a problem, but you're just kind of just hoping that there's not any problems that pop up at this point. And most of it's honestly out of your control, but you have complete trust in the team. This is where The reason we've trained so long and trained with these actual operators, the same people are in the loops, is if there are any issues, you can hear it in their voices. You work with them, you know them. Complete confidence in JSC and MCCX, the Hawthorne teams, and just actually looking forward to actually getting to execute what you've trained so long to do.
It makes sense. So much work and so much effort over the years has gone in to get to this point. You want to keep going.
Yep. Yeah, and it's and I think right now, just the final, my guess is what they're talking through is, so again, on those displays, they're probably looking forward a few events and talking through those. And so specifically, they are probably talking through the different launch abort phases. So you'll hear, once they actually lift off, you'll hear Stephen calling 1A, 1B, 2A. Those are the different launch abort stages. And what they're probably talking through right now is the timing of that, what things they're looking for on the displays, and just again, sort of rehearsing as much as you can, because once it happens, it happens really quick. So you're just kind of running through things over and over again. The other thing there.
Start of stage 2 offload.
Right. So there's the start of the locks being loaded on stage 2. You heard the call there, so things still progressing well. And so the crew has a timeline of these events. So that's another way they can kind of QC if things are proceeding, maybe if the fuel is taking longer or slower to slow, so they're kind of comparing where they're sitting on the clock versus those calls, and gives them a sense of how things are going. But there's no immediate direct telemetry in the Dragon capsule that tells you all the subsystems in the F9 rocket. You're relying on the timing and some cues and listening to these calls to know what's going on with the rocket itself. Once it launches, you have telemetry on the F9 engines, the status of the throttling command. So he talked about out at Hawthorne, the max Q event and the throttle down. You can see that, you can feel it. And actually, that was probably what I thought as one of the coolest things about our launch was that we could feel and hear the throttle down before we saw it in the telemetry. So for all the automation and all the coolness of electronics, I thought it was amazing and very awesome that the person could still beat the machine.
How about that?
But so that's kind of what since they don't have that insight to the F9 rocket, they're relying on the calls and the timing as they are sitting here now, and just making sure everything's on track.
Critical communications to the astronauts so they know exactly what's going on, as Raja mentioned. If you're outside and getting ready to watch this launch, you can hear it on the radio. It will be available on local amateur VHF radio frequency 146.940 megahertz and on the UHF radio frequency 444.925 megahertz FM mode, heard within Brevard County on the Space Coast.
So the next thing you should be, as we get closer to 10 minutes, they're going to make sure the launch displays are set up. And the reason they're going to do that is because once the launch happens, you have the ability all the displays are touch screen, so you can change them and move them, but you don't want to be doing that during launch. And so there's a check in there to make sure you have the views you want. Generally, what I'm guessing they'll do is they'll scroll on the procedure to where they expect to, so they don't have to scroll while they're under G's. They'll make sure that the mission specialists have the views that they need. You can see Andrey reaching up there right now, so they'll kind of check to make sure that their line of sight is not obstructed, and that one more check of probably the volume control of their seats, that everyone can hear each other. Maybe give it a few clicks to account for the fact that it's going to get a little louder after launch.
All right, let's get another update from SpaceX and check in with Kate Tice.
Thanks, Daryl. We are T-minus 13 minutes and 47 seconds from launch. Everything's still looking good for tonight's Falcon 9 launch for Dragon Crew 6. If you've been following along, you know that Falcon 9 began propellant load at T-minus 35 minutes. Loading of the RP-1 fuel on the second stage is complete. That finished around T-minus 20 minutes. Fuel loading on the first stage continues. It's approximately 75% full and will finish around T-minus 6 minutes. Densified liquid oxygen loading is underway on both the first and second stages. They are looking about 80% full on the first stage and just under 10% on the second stage. That will wrap up at T-minus 3 minutes and T-minus 2 minutes respectively. Checkouts of the thrust vector controllers, what we call TVC wiggles, those are coming up. That's basically when we use those thrust vector controllers to slightly move each engine nozzle. That's what allows Falcon 9 to steer itself during ascent. Dragon Mission Director and team are reporting no major issues at this time. Communication checkouts are complete. The crew access arm is retracted, as you can see there on your screen. It's nowhere in sight. The crew access arm, the launch escape system is armed, and the crew is strapped into their seats and ready to go to space. Final instructions to the crew will come at T-minus 10 minutes. The crew displays will be configured for launch. That setup gives the crew insight into how the launch is proceeding and provides constant updates on vehicle health. You can see the crew there on the right-hand side of your screen now, looking pretty comfortable. At T-minus 5 minutes, we'll be in terminal count, and Dragon will then transition to internal power. We'll hear continued call-outs on the countdown net as we continue to get closer to liftoff. As for the range, they remain green for launch, ready to go. Weather also still looking really good. Winds down to 4 miles per hour coming from the west. Only a 5% chance of violation for the criteria, so continues to look good. I'm sure if it was daylight, it would probably be a cloudless sky for the most part there at Kennedy Space Center. So with that in mind, let's go back to Daryl at Kennedy as we continue to approach liftoff just under 11 and a half minutes from now.
All right, good call-outs there, Kate. Appreciate that. Some final thoughts from the commander of Crew 3 before we watch Crew 6 lift off.
It's a great time to be. You'll hear them in a few minutes when they make the 10-minute call and confirm their displays are ready. The crew will probably give a message thanking folks and just the thoughts on their mind. There's a lot of work and a lot of people that worked a long time to get them here, and it's a pretty special moment.
And when they lift off, they'll be 260 miles over southwest of New Zealand. And with that, we want to focus on the pad now as we proceed through the final stretch of the countdown. We'll turn over to Gary and Kate at SpaceX headquarters in Hawthorne, California, to take us through launch and ascent.
Thanks, Daryl. The energy is certainly starting to grow as we get closer and closer to T0. As you can see the vehicle there at pad 39A, that's Falcon 9 with the Dragon capsule positioned on top. Now we're going to go through a couple of things, including some physical changes to the pad, but you will likely hear a number of call-outs after liftoff that are basically indicative of the various abort modes that Dragon passes through during flight.
Now T-minus 10 minutes.
Dragon, SpaceX, confirmed crew displays are configured for launch.
SpaceX Dragon crew displays are configured for launch.
SpaceX copies. On behalf of our entire team at SpaceX, we are honored to have you aboard Dragon Capsule Endeavour today for its next trip to the International Space Station. We wish you a great mission, good luck, Godspeed, and enjoy the ride.
And thank you very much for those kind words. We'd like to thank all the trainers, technicians, engineers, decision makers, and planners who have defined our mission ahead and trained us and given the faith and now to execute that mission. And Crew 6 is ready to launch.
Those words coming from the Crew 6 inside the Dragon right now, under 9 minutes from launch. Those final instructions meaning we are in terminal count. Falcon 9 launch commit criteria is getting checked by the computers. And we're in the final stretch here, inside 10 minutes until liftoff. Kate was mentioning a series of number and letter combinations that you'll hear upon ascent once we get to that point. That'll be those different abort modes that we'll be tracking throughout the ascent. There's an Alpha and Bravo on the first stage, and there's 2A through 2E on the second stage as we track it up the eastern seaboard. Right now coming up on T-minus 8 minutes. The next major milestone that we'll be hearing will be about the engine chill.
That's right. That's a important step of the countdown. That's basically when at T-minus 7 minutes, we will open the pre-valves of the engines to allow a little bit of the super chilled liquid oxygen into the Merlin turbopumps prior to the full flow of LOX that occurs during ignition. Now, that's important because at this point in time, all the hardware is at ambient temperature. So by opening the pre-valves and flowing a little bit of that super chilled, densified liquid oxygen helps prepare the hardware for that colder temperature when the full flow of LOX occurs. We should hear that call out in about 10 seconds.
Engine chill.
And there's that call out indicating that those pre-valves have been opened, and now there's a little bit of that super chilled liquid oxygen flowing through the hardware, basically chilling it out and prior to liftoff.
That's right. In the meantime, we're tracking fuel on the vehicle. Stage 2 RP1, or the fuel on the second stage, is complete. It's one of the earlier tanks to be completely filled in the countdown. But as we continue to track the fuel loading, the next thing will be the stage 1 RP load.
Complete.
That's coming up here in about 15 seconds. Later in the countdown, we'll be tracking the tanks of oxidizer being completely filled.
That RP1 load is now complete on the first stage. So at this point in time, all RP1 is now on Falcon 9, both for the first and second stages. LOX load continues, wrapping up at about T-minus 3 minutes for first stage and T-minus 2 minutes for the second stage. Coming up, we'll hear the call for Dragon to...
Dragon SpaceX, for awareness, we are seeing a TEA-TEB load issue and are troubleshooting. We are currently still go, but have further evaluation before making a final decision. We'll get to a final read before T0.
And SpaceX Dragon go.
That call out there just communicating to the crew that the launch teams are troubleshooting a small issue with TEA-TEB, and they will have some more information for the crew in the next couple of minutes. That TEA-TEB, as I mentioned earlier.
Dragon isn't configured for terminal count.
And there's that call.
Tanks are pressurizing for strong back retract.
A lot of information coming through right now, just indicating that that Dragon is now on internal power, and now we are basically preparing to retract the strong back, which is the white structure there to the right of the rocket. We will see the clamps open just under the Dragon trunk. Those will begin to open, and the strong back will retract away from the vehicle.
Yeah, that's right. We'll see those clamps on the top of the structure there, just under the Dragon's trunk, which you can identify by the black solar panels on the left of the base of the capsule itself and to the right. And then the structure itself will lean about 2 degrees, and then it will retract the rest of the way once Dragon actually hits that T0 mark and lifts off. We're seeing those clamps being undone now. The 2-degree lean will be very subtle, and then you'll see it more when we hit that T0 mark.
That's right. At liftoff, Falcon 9 will, the TE will actually retract to 45 degrees to clear the way for Falcon 9. That TE is basically what has the umbilicals that attach to the vehicle that provide power, telemetry, and fluids prior to liftoff.
Coming up in 10 seconds, we'll be listening for a call on stage 1 liquid oxygen load being complete.
Dragon is in terminal count and on internal power.
On his 2 minutes 30
The
seconds.
LD on countdown 1. Hold, hold, hold. We're staying down due to a TEA-TEB ground issue.
As you just heard, we
Launch
have
support head started.
As you just heard, we have a hold tonight due to the TEA-TEB issue that I mentioned prior, and the
Dragon SpaceX with that call from LD. You are go to step into 5.100 launch scrub.
5.100 launch scrub. That's in work.
as with everything else, we are prepared for all scenarios, including, unfortunately, as we've seen tonight, a scrub. So the teams are now stepping into those procedures.
That's right. Again, it was the teams were tracking a ground issue with TEA-TEB. That's the ignition fluid that actually sparks with the oxidizer and allows the engines to fire. The teams were tracking this issue, and so we're in a nominal scrub configuration. Start to see sort of a sequence of reversing some of the milestones we've been tracking as part of this countdown until the crew access arm swings back to the side hatch, and so the crew can egress the vehicle as part of a nominal launch scrub.
So for those of you just joining at about just under T-minus 2.5 minutes, we unfortunately had a scrub due to a TEA-TEB issue with the ground systems. So as Gary mentioned, we are in a nominal scrub configuration. There we have our procedures now being enacted to basically reverse all the progress that we made this evening, including propellant offload and bringing that crew access arm back into position and getting the astronauts out. Up until that point, everything was looking good. The ground team had reported that issue. I believe it was around T-minus 5 minutes. At this point in time, the launch escape system is still armed, with the crew continuing to look comfortable there inside Dragon Endeavour.
And Dragon, LD on countdown 1. At this time, our offloads are underway. Vehicle is safe and proceeding nominally with offload. Expecting about a 50-minute offload.
SpaceX Dragon copies about a 50-minute offload. We'll be sitting here waiting.
So it will be a very methodical process to offload the Falcon 9 with the propellant and oxidizer. You can see some of that oxygen billowing off still. That'll be part of the sequence. They've also re-enabled auxiliary power by umbilical to the Dragon as they work their way through the nominal scrub timeline. Again, that's a 50-minute offload. For those, again, that are joining, we are in a scrub situation just under 2 minutes and 30 seconds from launch. Teams declared a scrub due to tracking a ground issue with TEA-TEB. This is the ignition fluid that's used for the first and second stages that ignites the oxidizer for igniting the engines themselves to lift Dragon and into space. They were tracking this issue and declared a scrub again at the 2-minute 30-second mark. So we're going through a nominal scrub with a 50-minute fuel offload. see the strong back clamps have been re-enabled in this view right here. After we offload prop, we'll see the crew access arm swing back to get the crew out. In the meantime, the launch escape system, which enables the super Vacos to fire should there be any anomaly with the Falcon 9 during the offload procedure. The crew does have the ability to perform a pad abort. Right now, the ground teams are tracking no issues, everything going according to plan for a nominal scrub. All right, for those who are just joining, as a reminder, we are in a scrub, just under 2 minutes, 30 seconds from launch. The ground teams declared a scrub as they were tracking a ground issue with the TEA-TEB ignition fluid, and as a precaution, made a scrub for today's launch as we were counting down to T0. Now we're working our way through nominal scrub procedures, which include offloading the fuel and oxidizer that are loaded on the Falcon 9 right now. You can see we made our way through the countdown to a strong back retract that has been put back into place, and the clamps just under the trunk of Dragon are now in their configuration that they were prior to that part of the countdown. And Kate, we're making our way through offloading that Falcon 9.
That's right. In total, that prop offload is expected to take 50 minutes, 50. So unfortunately, at this point in time, there's not a whole lot that the crew there can do except patiently wait. I could imagine that they might be a little sad as of because otherwise they would be in space at this point, effectively. But right now, as you can see, they are just sitting back and relaxing as the Falcon 9 teams on the ground continue to keep them updated. As Gary said, this is a nominal scrub procedure or configuration. We have procedures listing out every step of this. So right now we are basically unfueling Falcon 9 from both the first and second stages, as Falcon 9 was nearly fully loaded at the time of the scrub. So as this continues, we will see some puffs of white clouds like you just saw there live, as that detanking effectively is underway. We will also see the crew access arm go back into the service position. That will enable the basically the pad team to re-enter the pad, go back up, and help the 4 astronauts that are currently there in the capsule basically unbuckle and get out of the capsule and make their way back down to the ground.
And it is going to be a methodical process. Like you said, Kate, through the fueling that began at T-minus 35 minutes, we made our way quite a bit through the timeline, and those tanks were pretty full. So the ground teams estimated a 50-minute offload of that fuel. In the meantime, the Crew 6 astronauts are in a passive state. They'll be tracking the fuel offloading process and listening to the communications from the ground teams, giving them status updates along the way. but we are in a nominal configuration. In the meantime, they've taken the Dragon Falcon 9 off of internal power and re-enabled auxiliary power back into the vehicle as they continue to go through this process. And like you said, Kate, it'll be a little bit, and then we'll see that crew access arm swing back, and they'll re-access the side hatch. If you were following along on our coverage, they walk down the crew access arm and enter the Dragon through that side hatch. They'll be exiting the same way. In the meantime, through this whole process, the crew and the Dragon itself will remain with the LES, the launch escape system, armed. So if in any event something were to happen as part of the offloading process, they'll be able to escape using the Super Draco engines, the 8 Super Dracos that are on the Dragon. It'll be a pad of 4 over into the Atlantic Ocean. But for now, all the ground teams are tracking that everything is nominal. The fuel offload is going as planned as part of a normal scrub, and we're just continuing to follow along.
That's right. And one thing I want to mention, although this is not what we had hoped to happen today, and while we said that this is a nominal abort configuration, technically the crew and the launch teams have already practiced this very similar scenario. On Thursday, February 23rd, the integrated launch operations teams, along with the astronauts, performed a full dry dress rehearsal, which basically means a total dress rehearsal, including suit up, transporting to the pad, going up the elevators in the crew tower, down the crew access arm, and ingressing into the capsule, and basically doing a full rehearsal of launch day as if it were real, but no propellant involved. So that's why it's called a dry dress rehearsal, because there was no propellant involved. So technically, this is very similar to what they would have done on Thursday in terms of simulating that scrub and basically having the teams go back up into the crew tower and retrieve the astronauts from the capsule. So at this point in time, we are following along with the procedures for this unfortunate scrub, but everything continues to track nominally for this activity. Right now, for those that have recently joined, we had a hold called on the countdown at about T-minus 2.5 minutes. The crew had reported around T-minus 5 minutes, or excuse me, the ground teams the SpaceX ground teams had reported around T-minus 5 minutes an issue with the TEA-TEB, which is basically the stuff that we use to ignite the engines on the first stage. So out of an abundance of caution, the teams called that hold at T-minus 2.5 minutes and then proceeded into nominal off detanking or basically unloading the vehicle with all of its propellants. Given the fact that occurred at T-minus 2.5 minutes, the majority of the propellants were already on the vehicle.
SpaceX with propellant offload update.
SpaceX Dragon, go ahead.
Offloads are proceeding nominally, anticipating another half hour until closeout.
Understand, looking about a half hour till close out.
All right, so good news there coming from the ground teams, indicating that we have about 30 minutes left of the propellant offloading. We heard Commander Steve Bowen sounding pretty unbothered by everything. Like I mentioned before, everything is written down in the procedure. They practiced this very similar egress procedure during Thursday night's dry dress rehearsal. So all in all, everything continuing nominally there for these next steps. As I mentioned before, we will see eventually the crew access arm swing back into the service position, and we will have the pad teams re-enter the pad area and basically enable the astronauts to egress. I also mentioned earlier that our backup launch opportunity is about the same time tomorrow, roughly 24 hours after our initial T0. Due to the fact that we were launching the crew that you see there on the right-hand side of your screen, they were headed to the International Space Station. As such, that is down to the very second in terms of catching up to the International Space Station when launching from Kennedy Space Center. So when it comes to crew launches, there's only one shot. And so therefore, due to that scrub that was called at T-minus 2.5 minutes, that was our only opportunity to launch today.
That's right, Kate. And as you mentioned, that scrub would be 24 hours. So we'll get to do this all over again. You mentioned the dry dress rehearsal. With a nominal offload of the fuel for this particular scrub, this is almost like a wet dress rehearsal, just taking it one step further. As you mentioned, for the dry dress, they did everything that we saw today, driving out to the pad, going up the elevators, and making their way into the vehicle, buckling up. The seats rotated, and they made their way far into the countdown, but before they started fueling the vehicle. Now, they fueled the vehicle prior to launch, and again, we're following a scrub that occurred at about 2 minutes and 30 seconds prior to the T0 time, due to tracking a ground issue with the TEA-TEB ignition fluid that's used on the engines to ignite them and fire the crew into orbit, and eventually catching up with the International Space Station. But as they were continuing to look at this issue, decided to declare a scrub for today. That scrub is, again, a nominal scrub, so we'll be going through the scrub procedures, which include the detanking. They seem to be going a little faster than originally predicted. They called out to the crew about 50 minutes. Now we're inside 30 minutes from detanking the Falcon 9. That's the RP-1 refined kerosene. And the liquid oxygen, that's the densified liquid oxygen that's on board, is being brought back into the lines that fuel them. So we'll be emptying those tanks. You can still see some of the oxygen, some of the gaseous oxygen billowing off the Falcon 9 rocket itself. So there is a little bit of fuel in there. You're seeing some of the puffs that are part of the detanking process. In the meantime, just a reminder that that launch escape system is armed through the whole thing just to keep the crew safe. But you see, for the crew themselves, it's a very passive experience to launch scrub. All of these commands being issued by the teams on the ground. They'll continue to wait until and get status updates from the ground teams. Right now, they are connected by umbilical. We did hear that as part of the normal countdown that Falcon 9 transferred to internal power, but they re-enabled auxiliary power back into the vehicle. So through the detanking process, we're getting power from the ground and not relying on the batteries inside the vehicles, so we can continue to work through this process. Again, Steve Bowen, Woody Hoburg, Sultan Alneyadi, and Andrey Fedyaev on board Crew Dragon Endeavour now, passively waiting for the scrub process, detaking fuel first. This is going to be one of the lengthier processes before the crew access arm swings back and allows the crew to egress or exit the Dragon vehicle and get back on the ground. We'll do the same thing again in about 24 hours, witnessing the same series of events, suiting up in the suit room before going down and making their way over to the pad via Tesla until they make their way up the launch tower, the elevators over there, and make their way back into the same vehicle. We'll continue to follow along and give you updates as we hear them. Right now, really it's just the detanking process, which is quite a lengthy process, so we'll continue to keep you updated there. That is still underway. That's one of the longer events that occur as part of a normal scrub. Left to right, Andrey Fedyaev, Woody Hoburg, Steve Bowen, Sultan Alneyadi on board Crew Dragon Endeavour now. Now we'll continue to follow along through this process. But from here over in Hawthorne, we're now going to toss it back over to the Kennedy Space Center, where, again, we scrubbed at about 2 minutes, 30 seconds to take us through and continue to give us updates along the scrub process. Daryl.
All right, thanks so much, Gary. Back here at the Kennedy Space Center in Florida. I'm Daryl Dale, and I'm with Crew 3 Commander, NASA astronaut Raja Chari. And it goes without saying, Raja, it looks like you're going to have to wait on seeing your first launch. As Gary mentioned, we had a scrub at right around 1:43 a.m. Eastern Time. Got down inside T-minus 10 minutes, and they started to notice an issue with what's called TEA-TEB, and these are the chemicals that help ignite the Falcon 9 engines, all 9 of them. And as it turned out, it looks like there wasn't enough confidence in moving forward with the amount of TEA-TEB that was there to light those engines, and so we have scrub. From the astronaut's perspective, Raja, you're sitting in there. First of all, tell me about what kind of reacts.
Yeah, so I think it's good and bad, right? The bad side is obviously, you're ready to go, been waiting for it, but I think what's really encouraging and what, especially we're appreciative as the astronauts is knowing that everyone's got our back and that safety is the paramount thing. So as much as everyone wants to go, the right thing to do is obviously, in this case, to scrub. And so I think that's really easy to remember when you're in the seat and when you're dealing with, as you go through the process of de-arming the launch escape system, all those steps just remind you like, oh yeah, this safety's got to be first. I think it's also kind of a good deal because you get a free run through of all the events and the timeline. So now they've seen it all once. They have the wet dress, but now you've taken it all the way down to near launch, and you get another run of that, another run through the procedures. We talked earlier tonight about sleep shifting, so they're already sleep shifted. That's why we do it that way, so that they're, you can continue and no earlier than tomorrow another launch opportunity. So I think that's kind of what's going through the mind right now. You heard earlier the call up from the core to get into 5.100, so that's the procedure they're running now. Earlier in the night, they're using 4.100 is the procedure name, and that's with launch prep, and this is the scrub prep. And so as a rough rule of thumb, what they teach the crew is about as long as you were fueling, it'll take that long to defuel. So since we were pretty deep into the count, you would expect to take that amount of time to basically take all the fuel out of the rocket. So the big picture is the crew's going to stay there just like they were ready for launch with the visors down, completely restrained, because the rocket still has prop on board. So the launch escape system is still armed. So it is still a volatile machine.
There's propellant on board.
Exactly. So they still, so we still have to treat it as if it's ready to go, as it is ready to go. Then once the prop is all off, then they can disarm the launch escape system, bring the crew access arm back out, and then egress the vehicle. So essentially what we saw earlier in the night, just run back in reverse. And then I think it's also a good example, you mentioned like inside T-minus 10 minutes is when we started to see some ground chatter and know there was an issue. You didn't hear that on the loops to the crew. And one of the reasons is, we worked a lot in training to figure out like, what do you tell the crew, what don't you tell the crew? But generally speaking, if there's nothing the crew can do about something, or, in this case, there's an action being worked, then maybe it would maybe potentially only confuse the situation to give them extraneous information. In this case, once they had actionable info, like, hey, we're going to scrub, or we're looking at this, that's when they call it up, versus just peppering them with random pieces of information that may or may not be relevant. In today's case, it turned out to be was the case. But yeah, I think from the crew standpoint, this is something we, just about, honestly, our launch was the first time we ever had an event where nothing went wrong, because in all the sims you do, something generally goes wrong. That's the whole point. Right. So this is actually par for the course, that you're like, oh yeah, of course, of course something happened, because that's what always happens in the sim.
That's how you sim.
Yeah, that's how you sim. So I think it's unexpected, and with, I think we relearn this every time we launch a vehicle, whether it's Artemis, SpaceX Dragon, a Starliner, we always learn things, and you can never assume everything's going to go perfectly. So I don't think it surprises anyone. Not to say that they're not disappointed. There's still that.
That's probably the first emotion.
The first thing
reaction,
is like,
right?
oh man, but then like, oh, that's good.
Right.
They made the safe decision. But yeah, absolutely a little disappointed. But you're still going to get to go to space. We'll just maybe do it a day or two later.
And currently, according to SpaceX, when they initially made the announcement, it takes about 50 minutes to detank the rocket. Currently, we're right around a half-hour left in
Right.
that process. So we've gone about 20 minutes in detanking. As you mentioned, astronauts have to stay strapped in exactly where they are to wait it out as that propellant is detanked. And I found that you can kind of get a visual marker by what you see right here, right? You can see
That's some venting and
venting of the locks at the top, but then also just about as high as that condensation is coming off the
Dragon
rocket.
SpaceX with propellant offload update.
I'm getting an update.
SpaceX Dragon, go ahead.
Our stage 2 LOX tank is offloaded. We're still tracking about another 25 to 30 minutes here. Last estimate may have been a little low.
SpaceX Dragon copies. Thank you for the update.
So about halfway done.
About halfway, and you can see.
Yeah,
it's
you're
almost about
I
halfway down.
I actually never noticed that
Yeah.
before, but that's actually a really good insight.
And so now the astronauts are waiting in the capsule. SpaceX is looking at, and will look at after this procedure is complete, what's going on with the hardware. There is a launch opportunity tomorrow. I want to emphasize this is an opportunity if the team decides that they can turn it around in 24 hours. And that would be with a T0 of 1:22 and 29 seconds a.m. Eastern Time. Again, tomorrow, well, this would be Tuesday, February 28th, with a T0 of 1:22 and 29 seconds a.m. There is a launch opportunity. If NASA and SpaceX decide to go forward with that, our coverage on NASA TV would start at 9:45 p.m., both on NASA TV and our streaming platforms. Also, from launch to dock, that transit would be about 33 and a half hours. So if they decide to launch on that day, docking would happen on March 1st at 10:04 Eastern Time. There'd be a rendezvous, docking, and welcoming ceremony coverage on NASA TV that would start at 8 a.m. Eastern Time. And I say all that, again, with the asterisk that that is a decision that has yet to be made, whether or not
Absolutely.
they take that launch opportunity. There's going to be a time to look at this situation.
Right. So like we heard that it was the situation with the TEA-TEB, which is again sort of the, if you will, the igniter for the engines and making sure the fluid, there's enough fluid or sufficient fluid. So whatever the technical underlying of that problem that led to today, if that's something that can be resolved, and obviously that's something the teams will be diving into probably as soon as the prop is off the rocket. I'm sure they're going to be crawling all over, and that's one of the other logistical things that's happening here. So there's, once they start fueling the rocket as part of the countdown sequence and the crew armed the launch escape system, all the personnel around there also cleared out. And so right now there is no one really close to the rocket. So once the fuel is off the rocket and then the crew de-arms the LES, then people can approach again. So it does take some time for the vehicles and people and the closeout crew, just like it did to clear out the arm and prep it. They'll have to do the same thing to bring people back to the arm, re-prepare it to connect to the capsule. But again, it's actually in the long run kind of a good thing is when they do try this the second time, it means it'll go all the more smoother because they'll have got another rep of doing it. You mentioned the one thing, having a longer time to rendezvous, the 33 hours. Actually, that's kind of another little maybe a positive silver lining out of this, because I know for us, for Crew 3, we really enjoyed our time in the capsule. You spend so much time training in Hawthorne, training in Houston, and there's something special, I think, about being in a small vehicle. Yes, it's cramped, so I wouldn't necessarily want to spend 2 weeks in there, but more than a few hours is just kind of fun because
Stop, catch your breath.
Exactly.
Relax.
Yes. Because once you hit the space station, you are on a tight timeline. Everything, every 5 minutes is accounted for, and it should be because it's expensive to get there, and we're doing a whole lot of science. The nice thing in the vehicle when you're just rendezvousing or waiting for those, we talked about phasing the orbits, you get time to just look out the window and hang out with your buds. It's kind of like a glamping trip. It's like, because you're sort of roughing it, but obviously it's some pretty nice digs.
But you can get out of your seat, right?
Exactly, and that's so it's a great time. Yeah, so once they get in orbit, and everything's checked out, they do get out of their seats, they can change out of their suits, and I thought that was some of the best time, both on the way up and the way down, just spending time in the Dragon and in the thing that you've trained in so long. And you can really hear it. It talks to you. You can hear when you do burns. You'll hear the prop flowing. You can see the thrusters out the window. So it's a nice time, and it gives you some time to adapt to space. So for especially our crew, just like their crew, having 3 rookies on board, getting some time to adapt to zero gravity, getting used to moving around, how you restrain yourself. The more time you can get in the Dragon, the quicker you can adapt and get to work on the space station. So I think it's all time well spent when you have a few extra hours in the Dragon.
Raj has talked a lot about the crew and what that means for them potentially going forward. I want to go back to the TEA-TEB. We've mentioned this, we've heard it a couple of times. I think one of our commentators actually spelled it out. If you look at the picture on the left, the SpaceX rocket on the pad, for those who are familiar with watching launches at night, that TEA-TEB, it's the ignition fluid. You can actually see it light because it flashes green all around the bottom of the rocket. You can see a green flash, and that's what it does. It lights those 9 Merlin engines, and then you have a liftoff. And they call it TEA-TEB because that's the acronym for triethyl aluminum, triethyl boron. And when they come together, they create that ignition that's necessary to light the rocket. And so that's something that SpaceX is going to look at. We also heard an update from SpaceX on the loops about the timing of the detank, which we are currently just about 27 minutes into that process. As astronaut Raja Chari was saying, this is a period of time where the astronauts just have to hold still while the propellant is taken out of the rocket.
And they're probably also going through, so we're always trying to think, what if? That's always what's going through our mind. So right now they're probably thinking through, well, the LES is still hot, so that was, but we're not planning on going, so if there was a problem, we'd probably hit the emergency ground egress button, wait for the crew arm to swing out at that faster rate.
Well, crew arm
Sorry.
attached,
yep,
right?
So but you would still want to, if you had to get out quickly, do the emergency ground egress. Make sure the LES is disarmed before you get out of your seats, and then egress if you had to. And so there's a few different ways, a few different types of egress if something else went wrong. And so whenever prop is moving, whether it's getting onloaded or offloaded, you're always ready for that.
So that LES stays armed through this process?
It actually stays armed. As long as there's propellant on the rocket, it stays armed. Because if there was any kind of contingency, you'd want to use that to get off quickly. The other thing that will have to happen eventually is they'll have to rotate the seats back. So just like we saw the seats rotate to the launch position, once the LES is disarmed, then they'll rotate back to the loading and unloading configuration. There's also, we didn't talk about it too much, but it's not just people that the Dragon takes up there, it's cargo. And so you can't really see in this view. We saw earlier in the night when they were first loading up, you got a shot underneath their legs. Yeah, exactly. And so you can see the cargo that's under there, and that the stuff on the left under Andrey's seat is mostly crew related in terms of like survival equipment. You see that red, you can kind of just see a red bag. That's the life raft. And so you saw that video earlier tonight. We talked about the Orion, the porch, and the Orion water training. So a lot of the water recovery equipment is in those pallets underneath Andrey's seat if the crew had to do something on their own for some kind of landing in an unplanned area. And then this stuff that's kind of under Woody and Steve's seats, you can see they look more like metal lockers. And so those positions actually have power. So under Andrey and Sultan's seats, there's no power to those locations, those cargo locations, but the ones under Woody and Steve, they actually have power, which means you can cool or heat things. But generally, when you're talking about science, going up and back from the station, oftentimes you need to keep stuff frozen or temperature controlled. And so those, usually probably the more valuable, I shouldn't say valuable, but like the more time critical stuff is in those. And so more than likely when they offload the crew, probably won't be on camera anymore, but they'll probably also go in and either take some of that stuff out if there's anything that has to be chilled or temperature controlled to make sure it's still in a good state. And then when you dock with the station, those are some of the first things that come off to make sure that they get into the right.
SpaceX with propellant offload update.
SpaceX Dragon, go ahead.
Offloads are proceeding nominally, expecting another 15-20 minutes here.
SpaceX Dragon, copy, thank you.
So Captain Stephen Bowen indicating with the launch team.
Exactly, yep, in about another 15 to 20 minutes. It sounds like things are going nominally. But yeah, so those pallets underneath there, like I said, they may, I'm not exactly sure what's in those particular ones, but it would not be uncommon to pull some of that stuff, they call it like late load cargo that, it's very sensitive to temperature or maybe some power considerations that you would pull off and store. And then, like I said, when you dock, those are the first things that come out. But again, if the kind of takeaway is it's not just people, but a whole bunch of stuff that goes to the space station by way of the Dragon. And then you can also put things in the trunk as well. On like the cargo Dragons, we saw it earlier tonight, the solar panels. You can load things into the trunk. Here's a great shot of it. So that bottom section that looks with the solar panels and the black and the white inside there, you can actually put things inside there as well. That obviously doesn't have to be in a nice atmosphere, so it's things that can be exposed to vacuum.
All right, good stuff. NASA astronaut Ranja Chari keeping us informed and updated on what the astronauts are going through and what it means for the cargo on board. We'll now take a moment to go back to SpaceX in Hawthorne, California, and get caught up with our NASA commentator, Gary Jordan. Gary?
Hey, thank you, Daryl. Yeah, we're following along here in Mission Control Hawthorne. As you mentioned, that status update on the fuel offloading, we're looking at about 15-20 minutes until that is completed. In the meantime, you see the Crew 6 astronauts on board inside Crew Dragon Endeavour, passively waiting. They'll be going through a series of more steps once fuel offloading is complete. In the meantime, the Dragon is going to, or the Falcon 9 is going to continue to get rid of the fuel and the oxidizer that's inside the Falcon 9. The seats themselves will rotate from the launch position down so that the closeout team can come back and get them out of their seats. They'll open up that side hatch and get the crew back, walk down the crew access arm, down the elevators, and go back to crew quarters to await for the next launch attempt. Right now, the next launch attempt we're looking at is about 24 hours from now. But right now, if you're just tuning in and looking for updates on the launch of the Crew Dragon to the International Space Station, we are in a launch scrub situation. So at about 2 minutes 30 seconds, the ground teams declared a scrub due to tracking what's called a TEA-TEB. This is the ignition fluid that allows the engines on the first and second stage to ignite and propel the Falcon 9 and the crew into orbit over the 9-minute ascent. Usually if you follow our coverage, TEA-TEB, when the second stage ignites at about 3 minutes into the flight of the Falcon 9, there's this green flash that you see from the MVAC engine at the tip, and then the titanium stabilization ring at the end of the expansion nozzle goes away after that TEA-TEB ignition and the second stage ignites. That green flash is the ignition fluid, and you can actually see it in our launch coverage. But it was that the ground teams were tracking, and so they identified a ground issue and are now going through the stages of a nominal scrub situation. Just regular tank offloading. We were originally looking at about 50 minutes of tank offloading. Now we're about 15-20 minutes from the latest report of the ground teams. In the meantime, the Crew 6 astronauts are aboard, passively waiting and tracking the fuel offload. And why don't we check in with Kate for more on the scrub situation?
Yeah, thanks, Gary. I am following along with the SpaceX ground team's procedures as we are continuing through this nominal scrub. As we heard called out a couple minutes ago, we have about 15 to 20 minutes left of the offload, so that should wrap up between around between 2:30 and 4:30 a.m. Eastern time. So we're coming up to that soon. Everything progressing nominally. Looking at the current levels, I'm expecting a call out to occur any minute now, indicating that all RP1 has been detanked from the second stage. So liquid oxygen detanking has already completed from the second stage. So I'm expecting that call out to come any second now, indicating that RP1 has been completely detanked. As for the first stage, also really low levels there. I would say less than 5% remaining locks on the first stage to go, and then probably about 10% fuel left to go there on the first stage. So we're nearly there, but we will hear those progress call outs on the loops informing the crew. As you can see there on the right-hand side of your screen, they remain comfortable in their seats, visors down, seats rotated back. The launch escape system is still armed at this point, although from that view of the pad on the left-hand side of your screen, it might kind of look like the crew access arm is reaching toward the capsule. It's not. We have not moved that yet into the service position, and we won't do that for a little bit yet. But we still have a number of things that we're going to go through in this nominal offload procedure. As I mentioned before, the crew had a dry dress rehearsal on Thursday night, meaning no propellant involved. So that's what makes it a dry dress. But they have gone through this very similar procedure in terms of the closeout team going back up into the tower, back down the crew access arm, and helping the crew get out of the capsule, including reopening that side hatch. So the astronauts will egress from the capsule the exact same way that they ingressed, just in reverse. So pretty simple from that standpoint, but there are also other things that we'll have to do in addition to that fuel detanking or offloading and the disarming of that launch escape system. We will also check with the hypergol sensors, those hypergolic fluids, monomethylhydrazine and nitrogen tetroxide, that MMH and NTO. Those are the fuels that are used to power Dragon when it's in orbit, and they are toxic to humans to breathe. So we will engage those sensors and make sure that there's a zero, that there's no presence of those propellants prior to allowing the closeout team return to the White Room. We'll also make sure that the closeout crew themselves are prepared and ready to re-enter the BDA, or blast danger area. So it's basically everything that they did earlier today, but in reverse. And then another thing that we will also do is we will release the range assets. So of course, all of that all that sea and airspace that we had closed off in preparation for launch. After that launch escape system is disabled, we'll be able to basically release or free up all of those range assets that are still currently locked down, just in case a launch abort, a Dragon abort, a pad abort in this case, would be triggered. But as we mentioned before, everything continues to progress nominally with no issues.
Dragon SpaceX with a propellant offload update.
SpaceX Dragon, go ahead.
At this time, we have RP1 in locks off of stage 2, expecting just another 5 minutes or so here until we are fully offloaded.
SpaceX Dragon copies, thank you.
So that was SpaceX Core Arthur Burialt, just informing the crew that there's about 5 minutes remaining, as I mentioned before. At this point in time, the second stage is now completely, or mostly empty, completely empty of its propellants. The LOX tank on the first stage is nearly empty, and the fuel tank on the first stage has maybe about 5% remaining to be pulled out. So everything continuing nominally with this offload. We heard there Commander Steve Bowen. As I mentioned earlier, he sounds pretty relaxed and cool as an ice cube here, and for good reason. The astronauts train for every possible scenario, this included. As we've mentioned several times before, we have procedures for everything. I am following along with this scrub procedure, and everything continues to go as planned, which is kind of funny to say for an event that we obviously didn't want to happen tonight, but as John Innsbrucker reminded me a little bit ago, the Mercury flight director said back in the early days of the space program, it's better to be on the ground wishing you were flying than to be flying wishing you were on the ground. So this is a good example of the system doing exactly what it was supposed to do. In the case of off-nominal TEA-TEB readings, there was a scrub called at about 2 minutes and 30 seconds prior to liftoff, and that was an issue that the crew had that the ground teams had informed the crew of around T-minus 5 minutes, had indicated that they would need a couple more minutes to troubleshoot the problem, and ultimately called that scrub at T-minus 2 minutes and 30 seconds. So at this point in time, the crew remains in their chairs. Unfortunately, not a whole lot for them to do other than continue to monitor using their crew displays, continue to monitor the progress of the propellant offloading and the overall vehicle health. But as I mentioned before, the commander's tone of voice indicates that everyone is, I'm sure, disappointed that they didn't get to go to space today, but unbothered or not worried about what we're walking through, as we have practiced a similar scenario very recently with that dry dress rehearsal just this past Thursday evening. So after we fully detank the vehicle, we will be able to disarm the launch escape system and then bring that crew access arm, which a great shot there on the left-hand side of your screen of it stowed away. We will basically rotate it back into its service position, and the close-out team will, I guess it will be the opposite, more of like a close-in team. They will return to the pad and go back up to the side hatch, reopen it, and help the astronauts out of their seats.
That's right, Kate. And again, we're getting that live view from inside the Dragon. They are passively waiting. It's the ground teams monitoring the detanking process, which we're really just minutes away from finishing. In the meantime, we continue to keep that launch escape system armed just to make sure the crew is safe through the process. Now, after that detanking is complete, one of the next steps will be to disarm the launch escape system. When the Falcon 9 is not fueled, it's in a safe configuration to go ahead and disarm that and go through the next series of steps, including that crew access arm swinging back and retrieving the crew. Now, Crew 6 will have another opportunity to launch. Right now, we're tracking a 24-hour turnaround for the next launch attempt. Of course, the teams on the ground will have to evaluate and continue to evaluate the issue that was identified as part of today's launch scrub. And again, that was a ground issue identified with the TEA-TEB ignition fluid that allows the first and second stage engines to ignite and propel the Falcon 9 and the Dragon into orbit. So they'll continue to talk and discuss about the issues before going ahead and proceeding with that next attempt, but we have that identified. If we were to proceed with a launch attempt tomorrow, again, today's launch attempt, we were counting down to 1:45 a.m. Eastern time. For tomorrow, for a 24-hour scrub, it's just about 24 hours, a little shy of that. So we'd be looking at about 1:22 a.m. Eastern time tomorrow for our next attempt. In the meantime, we're continuing to follow along, just really minutes away from completely detanking the Falcon 9. So we'll continue to follow along and get this next status update until that's completely detanked and we hear that they're disarming the launch escape system. All right, so Kate, we're continuing to follow along. Really just sitting and waiting at this point for that detanking process. But we should be expecting to hear something from the ground teams very shortly.
Yeah, that's right. We continue to see the crew remaining buckled in their seats, keeping their hands inside the ride at all times, for a lack of a better analogy. Yeah, their visors remain in the closed position. This, of course, is, as you just mentioned, the launch escape system is still armed. So while it is armed, the crew will stay exactly as you see them now. This is just in case for some reason, a Dragon pad abort is required. As I mentioned before, not likely, but it's a good backup. Of course, crew safety is the top priority at all times, even as we work through this nominal scrub procedure. So we will see the crew remain like this until further notice, basically. Checking in on vehicle status here, as I mentioned before, the second stage completely empty of all of its propellants. The first stage LOX tank also basically completely empty. I'm seeing a tiny little bit of fuel, that RP1, rocket propellant 1, still coming off of the first stage tank there. But for the most part, Falcon 9 is basically entirely empty of its propellants at this point in time. So as I mentioned before, we were expecting this to wrap up sometime between 2:30 a.m. and 2:40 a.m. Eastern time. So now at 2:33, we are in that range. So we should be hearing momentarily from SpaceX core Arthur Berrialt, located here at SpaceX Hawthorne Mission Control, just behind Gary and I. We should hear from him soon, indicating that the propellant offloading is complete and that we will then prepare to disarm the launch escape system. So for those that have recently tuned in, we had a nominal countdown. The SpaceX teams reported a issue with the TEA-TEB, basically the fluids that we use to ignite the Merlin engines. You can kind of think of it like the spark plug to your car if you drive a combustion engine vehicle. So that TEA-TEB is for that engine ignition. So we heard around T-minus 5 minutes that the SpaceX teams were troubleshooting an issue, and then about 2.5 minutes later, at T-minus 2 minutes 30 seconds, there was a scrub called in the launch countdown. But as I said, prior to that, we had a nominal countdown, and now just working through this scrub procedure.
Dragon, SpaceX with a propellant offload update.
SpaceX Dragon, go ahead.
At this time, we have all propellant off the vehicle and are proceeding with nominal closeouts.
SpaceX Dragon copies.
All right, so that's an important call. Propellant load, or the propellant offload rather, being complete. So we'll be tracking to see when the launch escape system gets disarmed. Right now it's still armed, just as a precautionary measure as the ground teams continue to track the
Dragon
propellant.
SpaceX, with that call, you are go for section 2 of 5.100 and disarm launch escape system.
Alright, and I'm not sure what call that was that you're referring to, other than that we are go for 2
And hold, break.
Launch escape system safety.
And copy that. Good read back, Dragon.
Okay, we are in launch escape system safing. We are 2 Alpha 1, and we're at 2 Alpha 2, but just on the launch escape system.
So again, if you're just tuning in, the ground teams we're tracking propellant offload. So it'll be the crew themselves inside Crew Dragon Endurance that issues the command to turn off. The launch escape system will wait for confirmation of that command being successfully issued to the Dragon system. All right, and it looks like we got that confirmation that the launch escape system has been inhibited. So that confirms the propellant offload and the launch escape system being disarmed. So the crew will work through a series of commands.
We're going to go with advisors and proceed to step 3. SpaceX Dragon, we are ready for steam rotation.
SpaceX copies will report when initiating.
Okay, so recap of what happened. We declared a scrub inside 2 minutes 30 seconds. That scrub time was actually 2 minutes 14 seconds.
Dragon SpaceX initiating
and we scrubbed for the day. Since then, we've been in a nominal scrub procedure, so it was followed. So we're continuing to follow along. And that crew access arm, we did get confirmation. You can see it visually, actually. It is swinging back into place to access the side hatch on the side of Crew Dragon Endeavour. So again, the Falcon 9 is completely offloaded with fuel and oxidizer, and the launch escape system has been disarmed. Those commands confirmed before going ahead and swinging the crew access arm back. You heard the command for seat rotation. You may be able to see that. For launch, the seat rotates up to about a 14-degree angle. That's the seat. That's the launch position. The seat rotation goes down to about a 40-degree angle to allow
the upright position.
SpaceX Dragon copies.
So there we can see the crew access arm closing the final inches as it moves back toward Dragon Endeavour. We are now pulling the closeout team to re-enter the BDA, or blast danger area. So as we've mentioned before, they will go back up the tower, back down the crew access arm, reopen that side hatch and help the astronauts egress from the capsule. As we heard called out earlier, the seats are back down in, so they were in the launch position. They've rotated back down into the ingress position. So we can see the crew access arm just closing the final inches up against Dragon Endeavour. At this point in time, we're going to head back over to Kennedy Space Center's Daryl for additional updates. I'm sure that they can see they were able to see that crew access arm move from their seats at the press site. Daryl, how are things over there?
Thank you, Kate. And yes, indeed, we could see the crew access arm coming back and making a connection with Dragon Endeavour. And as you see on the screen there, the white room, connected back in. And so as you watch, the astronauts can unbuckle and pull up their visors, take a moment to relax, and from here on, Commander Chari, looks like they'll be heading out at some point.
They should be, yeah. And at this point, the vehicle's pretty much completely safe. So with the LES disarmed or safe, There's basically no longer active prop in the F9, and also the Super Dracos are safed on the vehicle. So that completes their procedure 5.100, which is the one they're running inside the vehicle at this point. They're just waiting for the recovery crew to show up. Like was mentioned earlier, they have to stay outside an exclusion area while there's any potential of propellants or the abort engines kicking off. And so now that that's safe, those teams will approach the vehicle. See, they loosen their straps. One of the questions we were talking about while we were listening to SpaceX was why don't they just get out on their own, which they could. But we mentioned before that whole white room is a clean room, and so if they were to get out on their own, they maybe like scuff a boot, touch a hatch seal, and since all those things we want to keep really pristine, there's no rush right now. There's no reason to risk anything like that. Bumping a visor, scratching something, tearing a rubber seal. So the safest thing to do, since we're going to have to do this again on the next opportunity, is to let the closeout crew come and make sure they help them out, and make sure nothing is, nothing gets damaged or anything like that on the way out. And for the opportunity, this follow-on opportunities. The good news is the next opportunities will probably go faster because everyone's done it once now. So they've got some more practice. They don't have to sign the patch, like you said. They've knocked that out. So you save ourselves a few seconds here and there. And again, that's for the crew. Although there's some disappointment of like, oh, you didn't get to go, but it feels a lot just like another sim and another chance to go through the procedures, another chance because, like we talked about, once that rocket lights, things happen really, really fast. So the more times you have to walk through it and talk through it, and especially in the case like this, we're actually sitting in the seats with the displays up, hearing the vehicle sounds. That in and of itself is a worthwhile experience, and it makes you more perceptive if things aren't nominal. So the next time if you hear a sound, they're like, well, that's different than what we've heard before, and have a baseline for comparison. Looks like Woody's playing with his box settings, so now that their visor's up, they're probably changing their settings just so they're not getting background noise. You can see they're starting to get their gloves out, getting their hands out, and just get a little more, just cool off, and just kind of hanging out, relaxing waiting for the crew to come get them.
So Crew 6 did a dry dress just a few days ago. We could think of this as
a wet dress. Exactly, yep. This one had the problem.
So the more experience they get, the better off they'll be for the next attempt. Just to recap, if you're just joining us, we scrubbed the launch attempt at T-minus 2 minutes and 14 seconds before liftoff. There was a hold in the countdown, happened at 1:43 a.m. Eastern Time. The SpaceX team encountered an issue in the ground system affecting the loading of triethyl aluminum and triethyl boron, which together, the acronym TEA-TEB, they are the ignition fluids for F9. The ground team couldn't provide sufficient confidence of a full load of that TEA-TEB, which is important to light all 9 of the Merlin 1D engines underneath the Falcon 9. So the team scrubbed it, and now they're going through their procedures for a launch scrub. And so moving forward, we have some launch opportunities coming up for Crew 6. I mentioned the first one on February 28th. There's also another one on March 2nd at 12:34 a.m. Eastern Time. Yeah. And if we were to go then, we would begin our NASA TV coverage on March 1st at 9:30 p.m. And there would be a docking at 1:05 a.m. Eastern Time on March 3rd. Also want to make a note that there is no press conference tonight. Initially, that was scheduled. Had there been a nominal launch, but in this case, NASA is foregoing the opportunity for a press conference, and so stay tuned to your social media channels and NASA's official commercial crew blog.
We've pulled go for the closeout team to start re-entering the PDA, and they'll be back alongside you at the capsule shortly and helping you egress. Additionally, just want to do a quick comfort check, make sure you guys are still feeling okay sitting. EMC against that 1-0.
Wait for Captain Bowen to respond.
And SpaceX Dragon, we're all feeling good, just waiting on the opportunity to get out of the capsule.
All right, SpaceX, copies.
Yes, the call there you heard was that gives the crew SA that the recovery crew is going to be approaching, because if they do hear bumps or see shadows or silhouettes moving outside the windows, you can't see, you don't have direct line of sight into the room, but you can see maybe some movement or light changes, and that lets you know that's people, that's intended versus something off-nominal happening. And then a PMC stands for a private medical conference. And as you heard, they're doing fine, just waiting to get out.
And so that's going to do it for our coverage of Crew 6, first attempt of Crew 6 to launch the International Space Station aboard a SpaceX Falcon 9 rocket and Dragon Endeavour. Didn't get to do it today. Roger, you're going to have to wait to see your first launch. But good things come to those who wait. And so I want to thank you for being here.
Oh,
really
I appreciate it. It was a fun time. I'm sure I'll get to see a launch eventually. So as you mentioned, those follow-on launch opportunities, right now I'm sure the teams are going to be continuing to work through breakfast and lunch to figure out if they can fix the problem and when we'll be ready to go. But we'll go when it's safe and ready to go. So
absolutely. NASA's ethos will launch when we're ready. And so that's going to wrap up our coverage for this evening. Thank you for watching Crew 6's launch attempt to the International Space Station. I'm Daryl Nail for Raja Chari and everyone at NASA. Thank you for watching and have a great morning.
Emergency simulations of what the full mission will look like while seated inside a Dragon. And as with every mission, each one of our crew members brings a diverse set of experiences to today's flight.
That's right, and we'll start with the mission's commander. Steve Bowen was born in Cohasset, Massachusetts. He holds a bachelor's degree in electrical engineering from the U.S. Naval Academy and a master's in ocean engineering from the Joint Program in Applied Ocean Science and Engineering at MIT and Woods Hole Oceanographic Institution. In July 2000, Bowen became the first submarine officer selected as an astronaut by NASA. This will be Bowen's fourth trip into space as a veteran of 3 space shuttle missions, STS-126 in 2008, STS-132 in 2010, and STS-133 in 2011. Bowen has logged more than 40 days in space, including 47 hours, 18 minutes during 7 spacewalks. As the mission commander, he'll be responsible for all phases of flight aboard Dragon, from launch to re-entry.
Warren Woody Hoburg is from Pittsburgh, Pennsylvania. He earned a bachelor's degree in aeronautics and astronautics from MIT and a doctorate in electrical engineering and computer science from the University of California, Berkeley. He is also a commercial pilot with instrument, single-engine, and multi-engine ratings. The mission will be Hoburg's first flight since his selection as an astronaut in 2017. As pilot, he will be responsible for spacecraft systems and performance on Dragon.
Sultan Alneyadi will be making his first trip into space, representing the Mohammed bin Rashid Space Center of the United Arab Emirates. Aboard Dragon, he'll serve as a mission specialist, working to monitor the spacecraft during the dynamic launch and re-entry phases of flight. He spent time in the UAE military prior to becoming one of the first 2 individuals selected by his country when they started their space program just a few short years ago in 2017. Alneyadi will be the first